Hello, everybody. My name is Porter. I'm one of the CS128 Honors course assistants, and today I'm going to be talking about project structure because that was something that I thought was a little bit hard to find information on when I did my project. So hopefully I'll make it a little bit easier for you. So I'm going to start out by talking about how to configure VS Code for Rust development, how to organize larger projects in Rust with multiple files and things like that. And while I go, I'm going to be showing you a demo, kind of walking through making a small sample project. So first, we're going to start out by configuring VS Code. So I'm assuming you have Rust installed already. If not, you can just look up like how to install Rust and find this tutorial, which walks through depending on what type of machine you have, Mac OS, Windows, Linux. And this is a good tutorial, so just follow this. If you have any trouble, reach out and we can help you. But I'm assuming you've installed Rust by now. So if we go over to VS Code, the first thing we're going to do to get set up is install the Rust Analyzer extension, which is a great, I have it installed already, but just go to the extensions, look up Rust, find Rust Analyzer, install it. It adds lots of really nice features like warnings, errors, some annotation to see what you're typing, type annotation, thing like that. Um, it's super helpful, so I strongly recommend you install this. Okay, so now we're going to create a little demo project. So you can create cargo new to create a new project. Um, I call it my project, and I'm just gonna let this should load in here. Yeah, so I have this open in VS Code now. Um, just a little demo project with main hello world, and we can do if we go into this folder, we can now do cargo run. It compiles and runs this code, hello world. So we have a basic project. Okay, cool. So now we're going to go into the project structure in Rust. So um, packages and crates are the kind of the high level idea. So a crate is the smallest amount of code the compiler can consider at a time, and it's fully contained. So when you write a crate, basically that's something that you can compile. Anything smaller, you can't compile. Um, Binary crates are what you really do compile to an executable. It starts in a main function, and then you can run the executable like we just did, and it printed hello world. And the default crate root is in src main, um, and you can have other binary crates rooted in src/bin. So I'll show you all of this in a minute. I'm just going to get through this slide. So library crates are the other type of crate, which are not compiled to executables, but share functionality with other crates. So this is like in C++, if you think about including something, um, you're including essentially a library. And that's what library crates are for in Rust, for creating code to share with other crates for other people to use. And the crate root is always in src/lib for library crates. So then a package is kind of encapsulates at least one crate, but you can have many crates, right? So a package is kind of a vessel for organizing crates to build, test, and share. So if it's a binary crate, it's for building, right? You're going to build it, compile it to an executable, and run. Um, and that binary crate can be in a package that also has a library crate. Um, but then when you share the package, someone can include your package, specify your package as a dependency. And when they do that, it uses the library crate that exists in your package. Hopefully that'll make sense in a minute when I go back to VS Code, show you an example. So in packages, you specify dependencies, which basically are the other packages that your code needs to work, kind of like including in C++. And Cargo is the package manager that manages dependencies, including your own package. So we did that when we created our own little my project package. Um, you specify library crates that you depend on in the cargo.toml file. We'll see that in a minute. Um, and you can have as many binary crates as you want, but only one library crate. So that might be kind of confusing why you would want to do that, but just the way Rust is set up, you specify packages as dependencies. So when you specify a package, Rust needs to know which library crate you're using. So they just said by default, the library crate is unique in a package. Um, so let's go back to VS Code and take a look at what all this means. Okay, so main.rs is the default binary crate, right? And it is in src/main. When we do cargo run, it runs this, it compiles it to an executable and runs it. Um, so then we can add a bin folder to add additional binary crates. So um, I'll call this example .rs. And in this, binary crates need to have main functions so they know where to start executing. Um, so I'll say, hello to maybe. Um, okay, so there we go. Um, and if you notice this, like run, debug, things like that, when I get errors, that's from Rust Analyzer. Like if I do let x is 5, for example, this I32 came from Rust Analyzer. It's doing like type annotation. Um, so that's why Rust Analyzer is nice. Okay, so now we have this second x.rs binary crate that shares with main, that's in the same project. So my project is a package, right? Um, and it contains two binary crates now. So now if we do cargo run, it says it couldn't determine which binary to run because we have two. And it says we can run X, the one we just created, or my project, which why isn't not called main, right? Because this is called X and this is called main. So this is the default binary crate, which is in the root, which is in src/main. So by default, that binary is called the same thing as what your project is called. Um, so now we can do bin x to run hello to this new function we just created, um, or bin my project to run the original one. Um, yeah, so you can have in here, then you can add as many binary crates as you want, and you can have lots of different binary crates if you need. Okay, so then those get their dependencies from the cargo.toml file. So if you look in here, this kind of specifies information about your project right here, right? So this my project is a package and it has the name my project. This is like version information. And then in here, you're specifying what my project package needs to be able to run. So this is like equivalent to including things in C++. You can specify here what other packages you're going to be relying on and like what version they are and things like that. Um, and that comes in here. The cargo.lock file is automatically generated, not intended for manual editing. You can kind of just ignore it. Um, and the final thing is if we create a lib.rs file, this now, if someone else, some other project, specifies this new package that we created, my project, as a dependency for their project, their package, then it will use things defined in the lib.rs file to, that they can use. So like this, so the library, because it doesn't compile to an executable, does not need a main function. So like I don't know, you can define other something in here in this function, and then another package can include your project and compile it in within their project. So like that you can define functionality for someone else to use, basically. And you probably won't be using a lib.rs file in your project, but if you want to, you can. Um, yeah. Um, so I think that's everything for packages and crates. So now moving on to modules. Um, Rust modules are kind of a way for organizing things, basically, similar to JavaScript modules, if you're familiar, or C++ namespaces, kind of grouping functions together so it's more organized. And just like C++, you use the colon colon operator to access modules. And everything in modules is private by default. So you have to use the pub keyword to make things public. I think you're probably familiar with this. You can put modules in separate files for better organization. And you can access modules by using paths. So, um, Here's some examples. So you can get from anywhere, you can use crate colon colon as like kind of getting to the root of your crate, and then you can like kind of go up from there. You can use self to go from like the module that you're in. That's usually not really needed. It's like implicitly in there. Or you can use super to go up a directory, basically. So if you think about these paths to modules as similar to directories, it's like create is like doing slash to get to the root of your file system. Um, self is like doing dot slash to get to like your current folder. Super is like doing dot dot slash to go up a directory. Um, so we'll see some examples of all of these actually right now. So I'm just going to go through lots of examples of creating different modules and including things and things like that. So just to make things simple, I'm going to get rid of these. So this is nice and simple now. Okay, so we just have this main function. Okay, so first, um, you know, we can define functions. Like we can, if we start defining like a function here, um, so if I just make this in test, um, so then we can call this test function here. This is should be familiar. And then when we run our project now, it'll print that out as well. So once you start getting lots of files, lots and lots of functions, you want to kind of break this up, right? Because you don't want to have everything in one file, because then it gets super messy and cluttered and hard to follow. Um, and it's not very organized. So what we can do is in this SRC folder, we can add, I'll call it level one, let's say. So this is now going to be our new module. And let's move this test function into level one. Okay, so now test doesn't exist, right? So we can't access it. So what we can do now is if we do level one test, now this is going to say we can't find module level one. So this is like I was saying with the colon colon operators, we want to say go into module level one and find test, right? But this is recognizing this should be a module, right? But it says it's an undeclared creator module level one. So how do we get access to level one? Well, if we add in mod level one, then we specify. Now this isn't giving us an error because we're specifying, like we're kind of declaring that there is a module that exists in this directory src called level one. And now it recognizes level one. But now this is giving us an error that function test is private. So it can find test and it says, oh wait, I don't have access to that. So we can just make that public and then have access to it. So now when we run this again, we should get exactly the same behavior. Looks good. Of it's calling this function test from here. Okay, so now if we take this another level and say, well, what if we add so many modules in this SRC folder? Maybe the SRC folder starts to get cluttered, and that's not very organized. And we would like to have some sort of like hierarchy, right? So what we can do is in the SRC folder, create a we can create something exactly equivalent to having this level one. So what we can do is if we create a folder in here called level one, um, and then in the level one folder, create a file called mod.rs. It has to be called mod.rs. Um, having this folder with a mod.rs is the same as having this file level one.rs. So if we come in here and do that, and I'll delete this folder now, delete level one, having level one mod.rs is exactly the same. And hopefully this works exactly the same. Yeah, so level one is a module. Now it's still a module exactly the same as before, but it's in a file. And when you have mod.rs file in this folder, um, that Rust knows that this module has the name of the folder that it's in, basically. Um, okay, so great. We have now some more structure, some more organization. But what we can do, let's think about now if we want to add like another level of hierarchy. So we can create a new module. Let's call it level two. And notice this is inside of level one, right? Um, and then we're going to have another function. I'll call it test one, just so it's easy. Um, and I'm going to copy this so that we can have, I'll make this just to have it be extra clear. I'll say this is level one test, right? And this is level two test. Sorry, no, this is level two test, but it's in level one, right? So to get to the contents in this module, you need to first go through level one. And I'll say this is called test one. Okay, so now this says this is unused, right? Because we haven't used it. So now if we come in here, can we do level one, level two, like we want? Does it work? No. Why not? So module level two is private, right? Everything is private by default. So again, make this public. Now does it work? Well, still, test two cannot find test two in module test two. Similarly, test one. Oh, sorry. Well, this is called this one. Yeah, but still, it's not going to work because it's not public. Um, so we also have to make this public. Now, again, every function doesn't have to be public, right? You can have private functions in here um, that, like, we could do this, for example. This is fine. Um, right? Test one now will call private, which is private, and that should still work. So now if we run this, we get level one test and we get level two test one, right? We're going into level one, going into level two, and then getting this value. So great. So now we have kind of more structure. But again, this is getting we don't want to just define all of the structure in here. So similarly, you can this mod level two, we could bring that out into a let's say level 2.rs, right? So this is a module. Now, again, we could have a folder called level two with a mod.rs file in it. That's again equivalent. Um, but just for simplicity, let's just have it be a file for now, a module file. So now we can do this, and this is, the same as what it was, but now this is all kind of grayed out, right? Why is that? And when we look in here, level two says failed to resolve, could not find level two and level one. So clearly something is wrong. Um, and do you remember in main.rs when we did mod level one? That was like declaring that level one is a module that exists in this directory, right? So level one exists in the src directory with main.rs. We have to do the same thing in mod.rs for defining level one. We have to include basically level two. So now we're saying this module level two is a module that exists in this directory with mod.rs, this level two mod. And now this isn't grayed out. So now level one has access to everything in level two. So like in here, for example, we could add level two test, right? And this is fine. Um, I'm not going to do that though, just for simplicity. So this is still grayed out. Well, it actually tells you um, because level two is private, right? So we always have to make everything private if we need to like give it access. Um, but now we have something really structured. We have this first module, another level module. We can have this many modules. Um, so our code now is very organized. Now let's think about something maybe a little bit more interesting. Going back to what I was talking about earlier with these resolution operators, the create, self, super, things like that. So first, I'll point out something you can do to make your life a little bit easier. You can say like this. Um, we can say use. Probably what you would do is something more like this. Use level one, level two. So now you no longer have to specify that level two is inside of level one, and that still works exactly the same. Um, Now you'll notice if we don't specify this, it doesn't know what level two is. Failed to resolve level two because level two is in level one and it doesn't know that. So we have to tell it. Okay. And you can also even do something like this, test one, and then you don't even need to specify that, right? And that still works exactly the same. Um, okay, cool. So just for clarity, I'm going to bring this all the way back to what it was so we can see what's going on. Um, okay, so now if we look at level two, what if we look at, uh, well, actually, so I will say this, great, we can do this, and that's also exactly the same as this. Because we already are at the root of our crate, right? Main is at the root. So this says go to the root, which we're already there, so that doesn't really make a difference. Um, Now, if we're in here, we can do something like go to our parent, right? And our parent is level one, which has this test function. So what if we call test? Does that work? Um, let's see. So it's complaining about this unused. Import, get rid of the warnings. Okay. Okay, so now this calls first level one test, right? And level one test, and then level two test, test one, and then it calls again level one test. So this test one function is now calling private, which calls super test, which is it goes up a directory, right, or up a module, and finds test in level one. So then it calls that from there. So you can kind of go up a directory like that, and that's equivalent to saying this. If we go to the root and then go to level one and then go to test, that's the same thing. So now we'll just get this printed out twice in a row. So we're going to level one test from two different ways. Um, and those are both the same. Yeah, and so then like the self we could do that, which um you might want to do if you need to specify particularly what you're looking for, but that doesn't change the functionality because you're saying just go to my own module, so which was implied. Um, Yeah, so that's everything about paths.
So to recap all of that, a package is the container. It lets you build, test, and share crates. A crate is a small thing that's a tree of modules that's used to produce a library or an executable that you run. A module is something inside of crates that's used for controlling organization, scope, and privacy with the public keyword or pub keyword. And the path is what I was talking about, the absolute versus relative, self, super, and crate. Um, just useful for naming things to be specific about what you're trying to use. So I'm going to move on now to installing a example package in your project. So to do that, um, what you're going to want to do is use crates.io, which is a Rust package registry. And to learn about the crate, use docs.rs, which has documentation for a bunch of packages. Um, and also, packages might not have their documentation only on docs.rs, so you might have to look around. Um, Packages are also organized with modules, um, just like modules are used in other packages. So you might have to use the scope resolution operator, the colon colon, to access a module from within a package because they might have their package organized like that. So you might have to use the colon colon even when you're using external packages. And just a little note here: when you use a package from crates.io, you're using the package's library crate as opposed to the binary crates. So if you'll remember in our example, this was our library crate. We didn't do anything with it, but there's no way to compile that to an executable. It's just code for someone else to use. So when you make your project, you're probably going to be just working with main, right? You're probably going to only make one binary crate. If you wanted to, though, you could make a library if that's what you want your project to be. But you're probably not going to be using a lib.rs file. You can if you want, though. Okay, so let's take a look at crates.io. So this is basically just a website with a bunch of Rust crates. This is where all the crates are that you're going to use if you want all sorts of different things. You can search for any type of crate, look by category, recent keywords. So I'm just going to be talking about rand today. So this is just for using random numbers. And this is just going to be like my example, basically. So it tells you how to install it. There's a couple different ways. There's documentation on docs.rs. You can take a look at that if you want. Sometimes people will put their documentation in a GitHub repository. So maybe just look around if you're having trouble. But this says there's two ways to install it. So you can run cargo add rand, or you can put this in your cargo.toml. So let's do the cargo add rand. If we come in here and say cargo add rand, it says updating crates.io index, right? The cargo uses crates.io. That's like the repository of packages that it goes to for all of any library that you're going to want to use, any library package. When I say library, I mean like a package, which is using the library crate in a package. People will often it's strange because this is called crates.io when really it's a repository of packages. That's kind of what I was talking about before about the arbitrary decision to have a package include one library. So people will often use crates and packages interchangeably, even though they are different things. Crates.io is a repository of packages, and you use the library crate from those packages. It's confusing, and I didn't come up with that system, but that's the way it is. So we're going to be using the rand package, but the library crate from the rand package. So once we've done cargo add rand, it adds automatically for us this dependency. So when anybody else tries to use your package, let's say, cargo can look in here and say, okay, it uses rand. I need to install rand. Things like that. So this is just to specify like that you need rand and specifically what version. So if you want to use an older version for some reason, if there's like breaking changes that are released, if the rand package changes, you want to use a specific version. That's basically what this is for. And you just like write it in here and cargo will figure everything out for you. In cargo lock, this is just like information for cargo. You should never change this file. It says it's automatically generated by cargo. You can just ignore that, really. But now that we have installed rand, all we have to do here is, this is from the documentation. I just, you look through this, it'll say, okay, quick start, whatever, right? Read through the documentation, figure out what you want. I've read through it and I found I need to use rand prelude star. Let me just copy that. Here we go, come in here. Perfect, I'll get rid of this. Get rid of this. So you bring in rand and then, let's do this, hello world. And then just for a simple example, I have rand, random, I8. So you can probably already guess what this is going to do if we run this. And did you see that took a little bit longer? It compiled all these different things, and that's because we added the rand dependency in cargo.toml. It knows, okay, I need all these things now, so I'll grab those and compile them. Oh, and this is giving me all these errors. I'll just, I'll just delete this folder for now. We don't need that anymore. I'll get rid of this just to show you using rand. Perfect. We got hello world minus 86. So if we run that again, 26, 36. Oh, and this is unused. Does that? Okay. Guess I read the documentation wrong. So you should just be able to like access this rand without that. So basically that's installing your own package. You're gonna want to do this for any type of package, depending on what you want your project to be. Just take a look at crates.io. Maybe look for some examples. There's really a lot you can do. Random, for example, is a huge package with a lot of different a lot of different stuff when you start like digging into everything. But getting familiar with how to read documentation is very helpful. With Rust in particular, this docs.rs is a pretty uniformly formatted documentation. So if you kind of learn how to read this, looking through different structs, modules, functions, like these are all of the documentation for Rust modules is going to be formatted very similarly. So it would do you well to learn, kind of just get familiar with how to navigate these. And as always, I really recommend reading more documentation than you think you have to, just because it won't end up biting you in the butt if you really know about what's going on. That's just a little tip, I guess. But yeah, that's installing external packages. And with that, I guess I'll wish you luck on your project. It is what you make it. It could be a lot of fun if you put some good time into it and make a cool project. I know I had fun making my project, but it's up to you what you want to do with it. So good luck and have fun making it. If you have any questions, feel free to reach out. All right, see ya.